There are over 8,000 languages in the world, but in our lovely one called English, and probably many others, where you can write out numbers in words. This might sound obvious, but this gives rise to one number, maybe even more, that are more special than the rest. One such number is 22,041, and today we will find out what this hidden treasure is. It's not on the internet, you can only find it here. To a mathematician, 22,041 is not the most special of numbers. It is divisible by 9 and has 12 factors, but many numbers have 12 factors. That's what AI told me when I asked it. And when I searched up in the OEIS, as I'm about to show you, it didn't give very many results, and none of them were sequences that I knew. But to a non-mathematician, in fact to a linguist, 22,041 is quite a special number, and I will show you why right now. But before I do, try and pause the video and work out what makes 22,041 so special.
3, 2, 1!
I can't read your mind, but if you thought it was big, then you're right, but you're wrong, because it's a linguistic property. If you thought of the 12 factors thing, I just said it was wrong. So there's only one thing left. Actually, there are quite a few things left. But if you were thinking about vowels, then you might just be a genius. Because 22,041, when written in words, has exactly 2 A's. Wow, coincidence. The first digit is 2. Exactly 2 E's. You might see where this is going. Doesn't have a single eye. No matter how wide your eyes are, you won't find one. And it has exactly 4 O's. They're great big holes. I wish they weren't there. And it has exactly 1 U. Of course there's exactly 1 U. There's 1 me, there's 1 U, and there's one special number right in front of us. 22,041. The way to know there's only one is you could go the long way with trial and error and logical deduction, but the easier way is just to use some code, and that's up on the screen now. So, firstly, what is wrong with what I did last time? So, when I say 22,041, I'm not including the and when I wrote 22,041, I was including it. So what if we don't include the and? How does this work now? Obviously, my code is going to be a bit worse, but also, what is the new number? Let's see. This is interesting. When we remove the and, there are now 2 solutions, 13,232 and 17,011. When I use logic, I only found the second one. Logicians, you've waited long enough. Here's your problem. So now, instead of vowels, what if I think of a 5-digit number with or without the and that includes the first digit, how many A's, the second digit, how many B's, the third digit, how many C's, and so on until the 5th digit, how many E's. This you can actually solve with logic. You don't need any trial and error. So how can you do it? Believe it or not, you don't have to worry about 4 of the digits. The smallest number that contains a B is 1 billion. We won't be using it. The smallest number that contains a C is 1 octillion. We won't be using B's or C's. And then it becomes pretty clear that you will only have thousands and then a number at the end. And the smallest number that contains an A is 1,000. So you'll only have 1 or 2 depending on whether we use the and D's, it's the same thing, because we don't have any hundreds. Alright, so let's first suppose that we are using the and, so let's fix the 4 digits we know. So now we have 20,020, so there are 2 E's, so let's try adding a 2, and there are no more E's, so 20,022 is the solution with the and. 20,023 doesn't work because there are 2 E's, 24, there are no E's, 25, there's 1 E, there's never going to be enough E's after that. So 20,022 is the only solution. Moving on to without and. Let's fix the 4 digits 1001. And again, we have 10,000 and some teen. And let's just list out the cases. We already have one E thanks to 10. And then let's count the others. So if we have 11, then we'd have 3 more, won't work. 12, 2 more, won't work. 13 works. And then after that, everything pretty much has 2 more E's, except for 17 and 19, at which point the 6 or 8 needed is out of reach.